I'm going to show you the butterfly now, which is my way of helping you remember and use the unit circle. All that stuff that I told you in the long video, now we just do the short version of it, and so we can quickly answer finding exact values of trig ratios for big angles, small angles, anything that's not that 0 to 90 degrees that we've just been using triangles for before. This is a typical question that we would use the unit circle to answer. Find the exact value of cos 210 degrees. Now on your formula sheet, you are given these two exact value triangles. You can use them to find the sine, cos and tan ratios of 30, 60 and 45 degrees, but not 210. So what we do is we go to our unit circle and we go, okay, cool, 0 is here, 90, 180, 210's got to be about here somewhere. So I'll always put my angle of full rotation on the outside, and on the inside I'll put my little angle, which was the difference between that and the x-axis. So that was 180, that makes this one 30 degrees. Then I draw my line in. So this 30 degree triangle would match with this 30 degree triangle, having exactly the same width and height, but different x and y values. So I'm going to use this also as an example to explain the butterfly, as I said. If we were looking for 30 degrees in any portion, I could draw 30 degrees up there and 30 down here, and there's my butterfly. This is the spine of my butterfly. These are my wings, and this is where the wings cut. So you can see the wings cut the x-axis at a certain point. And the butterfly is on a leaf, which is on this twig. So I have a twig, a spine, and cuts. Maybe you might see where I'm headed. Sorry, bumped the camera. You might see where I'm headed with this. Twig, tan, spine, sine, cut, cos. So because I wanted the cos of 210, I've got to look at the value of the wing cut. Now here I can see that the wing cuts the x-axis in a negative position, but it would be the same as the one for 30 degrees. And since it's cos, the cos of 30 is root 3 on 2. So the cos of 210, cutting back here, is negative root 3 on 2. Say I wanted to do the tan of 210. 210, tan, I come up to the twig. And I can see that when I drag up to the twig here, it's exactly the same position as it was for the 30 degree one. So I look for the tan of 30 degrees, know that that's 1 on root 3, and go that tan of 210 is also exactly 1 on root 3, same value. I wanted the sine of 210, I look at the spine. The spine value of 210 is down here, the spine value of 30 is up here. Sine of 30 is a half. That value doesn't quite exactly look like a half, but it looks more like a half than it does like 0.9. Sine of 210, cutting on the bottom, negative a half. While I've got the rest of this butterfly, I could find out about 150 degrees too if I wanted. Say I wanted the cos of 150, that's this value, which will also be negative root 3 on 2. The sine of 150, same as it was for 30, so a half. Tan of 150, negative of the 1 on root 3. I could do the same for 330 degrees, or for negative 30 degrees, or I could come round to any point that will match back in this 30. I can use the exact values for 30 degrees. So whenever we're using a butterfly, we always track it back to the first quadrant answer and then go, was it positive, was it negative? Let's do another one. So I go 300 degrees, let's find it. First thing I need to do is work out where 300 is as a wingtip. So 180, 270, 300. 30 degrees in there, I don't want that one. I always want the one on the x-axis. So I want my 60 degrees because 360 makes the 360 for the full revolution. For tan, I need my twig value, which hits it down here, so it's negative. It's the negative of what it would be for 60 degrees. So I go back to this triangle and I look at the tan of 60 degrees and go root 3 on 1. So this will be the negative of root 3 on 1, which is neg root 3. Also, you can double check with your visuals here, because root 3 is, if you remembered it, about 1.7. This looks like about 1.7. This looks like about negative 1.7. You can start answering these questions visually. Your turn. Pause the video and give these guys a go. All right, 300 degrees. Wingtip, 270, 300, 60. Oh, it looks like a half. It's positive. Go back to my exact value triangle. 60 degrees, cos of 60. Yes, it's a half. 240 degrees. Find it on the circle. 180 plus 60 would be 240. X value cut is negative a half, but for sine I'm looking at the spine value, which looks like nearly negative 1. Remember, it's not negative 1 because we're here. It would only be negative 1 if we're right on the tip. And we're still looking at the comparison to that for 60 degrees in the first wing. Sine of 60, looking at here, root 3 on 2. So it's got something to do with root 3 on 2. It's the same height, but it's down here, negative. Root 3 on 2, if you put it in the calculators, nearly 0.9. So it makes sense again. Remember, sometimes the exact values are not going to be from that first triangle. There are other triangles you could use. There's this one down here that's got relationships to 45 degrees. And you can also just consider about where it lands on the edge of the circle. You might even just be able to see the answer. Pause the video and give these a go. All right, 225 degrees, find that, be here with 45 degrees after 180. The sine is the spine, so negative that for 45 degrees. Sine of 45 was 1 on root 2 from the exact value, so this will be negative. Notice how I just draw a circle for every question. It gets you good at drawing circles. 135 degrees is about here. 135, it's 45 degrees off 180 that way. The tan of 45 would come up here. Oh, bad drawing. Come up here if I had a correct drawing. Tan of 135 comes down here. I can actually see this looks like negative 1. If you do look at that exact value triangle, tan of 45 is 1. Tan of 135 is exactly neg 1. Over here, 180 degrees. This one isn't part of those triangles, but 180 degrees is right here. Our spine value, I'm not up at 1, I'm not down at -1, my spine value is exactly 0. Same thing with this cos of 90. 90 degrees is here. If I look at my wing cut at 90, well, there aren't any wings, they're going to cut straight through the middle again, so that one's also 0. But if I wanted the sine of 90, then I'd be looking up here, and now I'm looking at the spine value, so that value is 1. And the cos of 180, you might be able to see here, is going to be negative 1. So what we've done now with our unit circle is also answered a whole bunch of extra rules that you're going to have to learn and supposedly memorise. Now you don't need to, you just need to look at the circle. Here are another couple ones to try. They're all a bit different. If you want to pause it, have a go first. Otherwise, just use these as examples. All right. Negative 45 would be start at 0 and go backwards round the circle. Here, 45, spine value, negative. Sine of 45, 1 on root 2, so we are at the negative of 1 on root 2. 720, go around to 360, go around again, 720 is here. The wing cut value of that is positive 1. This one was a bit of a trick question, to be honest. If you put 90 degrees at the top here, and you consider if your hypotenuse was going like that, then like that, come up here, and you try to reach that twig, you're never going to reach it. They're parallel. Tan of 90 doesn't exist. 450, again, float around the circle till you get to 450. There's 360, another 90 makes 450 up here. Spine, 1.